Hi, this is my attempt solving the task scheduler question. I've had some, I attempted this problem, but I realized that I was doing it wrong and I need to approach it in a different way. So I'm going to solve this problem. So you're given an array of CPU tasks, each enabled with a letter from A to Z and a number n. Each CPU interval can be idle or allow the completion of one task. Tasks can be completed in any order, but there is a constraint. There has to be a gap of at least n intervals between two tasks with the same label. Return the minimum number of CPU intervals. So what we have here is we have an input of tasks, and let me draw this out so I can explain this. Okay, what? New graph paper create. Okay, so we have our input here. I'm going to draw a frequency map. So we have a tasks array filled with alphabets of characters that indicate that it is a task. So we have task A, we have 3 task A's and 3 task B's. N is basically saying how many intervals, how many cycles, what is the right word for this? How many, a number n. Intervals. Okay, n is the intervals that we need, minimum intervals between tasks. So if we had just used A, we can't use it before using n number of tasks in between that. So we used A, we can use B, but then we have nothing to use, but we do need to fill something in here because that's the number we need to wait at least n intervals to use A again. So this is how it's gonna go, right? We're gonna use this again. We're gonna have another idle. We have one more A's and B's, and that's it. So it's 1, 2, 3, 4, 5, 6, 7, 8. And yeah, output is 8. So that's the idea. What method I am going to use? The previous methods that didn't work for me was, well, creating a frequency map, making a heap out of it, making a priority queue out of it, and popping up one element at a time. That did not work for me. So what works in this scenario is you do the same thing. You make the frequency map, you make the heap. So it's gonna look something like this, right? So what you do here is you must realize that you have to pull out a k amount of nodes to use them in a single cycle. So if we assume that this is one cycle before another set of the same ones are used again, we have to use at least k. So this is 1, 2, 3, right? K is 3 in our case, which translate to n plus 1. So k is n plus 1. We must realize this. We must realize that we have to use n plus 1 amount of nodes if we don't want to idle. But if we have 2 executed, but k is 3, we must add k minus length of executed for the idles. This is the case because if we look at another case where, let's say n is 3, then we have to idle twice before being able to use A again. In this case, K is 4, right? So K is 4 here. We idled 4 minus 2 times. So that's how that calculation works. So as for the algorithm itself, we're going to first create a frequency map or a dictionary. So we have two choices here, either make the frequencies negative or positive. I think making it negative is fine for this case. And then just like making sure that we just use that value. So if we use positive, we're gonna have to manually add -1 to our frequency values when creating a heap, because we need to create a max heap with this frequency. And the reason why frequency is so important here, and we'll have frequency as the key of this heap, is because we always want to use the most frequent first. That is why we need to use a max heap with the frequency as our sort order, essentially. Then what do we do? So while we have elements in the heap, what we're gonna do is we will pop, so for thing in range, I just said thing, I don't really know what to say, underscore pop from heap, add this to executed, and each time we pop, we're gonna do intervals plus equals 1, meaning that we have used this task or executed this task. What else are we doing? Let me think. We're adding it to the executed, we're popping it from the heap, and we're adding it to the interval. I think that's all we do here. When we exit out of the heap, we have to push the ones that have frequencies greater than 1. So for task in executed, I guess we're going to store the task and the frequency. If freq greater than 0, wait, no. If the frequency is less than 0, we add it to the heap. Heap q dot push the frequency minus +1 task, something like that. Do we want to increase? Yeah, we do need something. So the final condition is that if the length of the executed is actually bigger, like 2, no, smaller than k, we have to add that much difference. So we have to add 2. If k is 4, right? To add intervals plus equal k minus length of executed. And I do believe this should be the case, but let me double check right now. Yeah, I think this should be good. Or maybe if the heap elements still exist, we add it. If length of executed, yeah, if heap, because if we don't have anything in the heap, there's no point. If heap. Yes, so we will implement this. This is honestly, this was not a bad question in terms of like acceptance rate. It was just really difficult for me because I couldn't just, I was just stuck on using the wrong algorithm. I was just trying to like pop one thing and then just try to insert that back, and then yeah, it was just a mess. So we're gonna do this approach, and I know how the algorithm works. Let's see how it translates to code. We're gonna first create frequency map. Right, I'll write some comments so I don't forget. Max heap with frequency, and iterate through the heap, and then return intervals. Okay, let's initialize some values here. Mapping is gonna be a dictionary for I in range length, or I guess we can just do tasks. For task and tasks, if task in mapping, okay, if task in mapping, we're gonna do task -1, else mapping task equals -1. We do this because we need a max heap. We need a max heap. So heap, we can just turn tasks into a heap. The key is going to be the frequency, which is the value, and the value is going to be the key, which is the tasks for key val in mapping.items. So that looks right. Now we need to heapify it. Okay, we initialize intervals to 0, k to n plus 1. What else do we need? Nothing else. While tasks. So while tasks, we're going to first define a executable, executed array for in range k. We're going to pop from the heap tasks. What do we do with the popped one? We add it to the executed. Popped. Well, that's just a tuple, so that's fine. And we add intervals plus equals 1. What else do we do? I think that's it. Pop from heap, add to executed. Okay, so now that we've done that, we have to look at this one for task in executed. For no, it's gonna be frequency and task in executed. I don't know if that's gonna work, but I'm just hoping that it will, because we're storing a tuple. That should be fine. Oh, we have to update the frequencies before we add it back, right? What? Frequency task. Frequency plus equals 1. Let me append it like that. Yeah. I guess we can just do freq plus 1. Just simpler, freq plus 1. And if the heap doesn't exist at this point, we have to break. Or tasks. Okay, that looks good. Let's just see this one now. Frequency and task and executed. We're gonna have to put those back in. If freq is greater than 0, we put eq heap push frequency and task. Okay. Now, after all that, if heap exists, right? Like here, if heap exists, where is it? If heap exists, we're gonna have to do intervals plus equals k minus length of executed. Yeah, and then return intervals. I think that might be correct. Oh, tasks. No. Uh-oh. What the hell happened? Did I put it back in? Oh, wait. If frequency is less than 0. We put it back in. Okay. See if this works for all the inputs. Yep, there we go. Okay. Oh my god, that is a tough question, man. That is a tough question. I just wouldn't have figured out that we needed to pop k number of elements in a million years, dude. So I had to look at the answer. But, I mean, I looked at the answer, I needed to know what to do, and I was able to translate the solution. I think that's worth, solving it again. And that was actually informative, very informative on how to actually solve this. And it's a new type of heap problem that I haven't encountered before. I am pretty sure I had an interview with Google, and this was the question I was asked. Of course, I failed that interview, but yeah, I mean, if you don't know how to solve this, I think you can probably like get away with it if you know heaps well. I just couldn't do it. But well, there's another archetype of problem into my brain, and we keep going. That's how these work, right? But yeah, I think I understood it pretty well. I think we're gonna skip the code iteration. It's a bit of a doozy for this one. There's a lot of for loops. But basically what it does is, I mean, let's just do it. Why not? Review the iteration of this code. Hold on. Let me take a screenshot of this code and go through this with you guys. It'll help me and you guys. Okay, so here we have a bunch of tasks. Well, we have initialized the heap at this point, so let's just draw the heap. I will assume we have a normal max heap without the negatives, because that's just easy to, you know what, let's just do negatives just to make it more accurate. But we must realize this is a min heap, but we're using it as a max heap. That's why the negative numbers. So frequencies, there's a number to count things. It doesn't matter if they're negative or fucking gay. Okay, so so here we have these numbers, heap. And the first thing we're gonna do, we have an executed list, right? This is a temporary list. It's gonna change for the range of k. K is well, n was 2, right? So k is 3. We're gonna pop 3 times, right? So let's see. We're gonna pop once. It gives us that. In the executed, we'll put a in here, right? And then we update the frequency plus 1. So this becomes b negative 3, a negative 2. Yeah? Yeah. So we have that there. Nice. Intervals is 1, right? Now we pop again, because we're not done with k yet. We pop again, we get b, and then we do negative plus 1 on that. B becomes 2, so this is b negative 2, and then a negative 2. We don't really need a tiebreaker in this case. Executed b. All is well until right here. If not tasks. Hold on, I am getting a call. But the main idea is you keep going.